hand this over to Sunny now, and just make sure you get as much as possible from these two lectures, and all the best.
Yeah, thank you, Sanket. And I hope you don't attend the lecture. You already know this stuff. So, hello everyone. Yeah, good evening to you all and good morning to me. Today we'll talk about 2 pointers. And yeah, if you are new, if this is your first class, don't worry, we are starting from scratch. So yeah, you don't need to worry. So let's start with the discussion of 2 pointers. And by the way, if you guys have any questions or if you don't understand anything in the lecture, just let me know. You can just unmute yourself and ask me questions. And if you write on chat, it might be difficult to track. So better way would be to unmute yourself and speak. Okay. Does that sound good?
Yes, sir. Yes, sir.
Okay, so let me share my screen and let's see how that works. Okay, can you guys see my whiteboard?
Yes, sir. Yes, sir.
Okay, so let's start with the discussion. So it's about 2 pointers. So pointers, as we might know from C++, it's like something which points to something, right? Like, let's say there is some memory in your, you have assigned some memory and then you can point it. So the idea is very similar. So what we are saying is we will have like two things which will point to certain indexes. So whenever we are talking about 2 pointers, you have to keep two things in mind. Like first is we are talking about linear data structures. So example of linear data structure would be arrays and linked list. Okay. And what 2 pointers mean is, let's say you have this array. So I'm drawing a linear data structure. So linear data structure would be a container where you put things linearly, like in a line, in a linear order. So I've put elements next to each other, so they are like lined up. And 2 pointer would mean that I'll have two indexes pointing at any point of time. So this is my pointer 1 and this is my pointer 2. So these are the 2 pointers. And similarly in linked list, right? If you guys are not familiar with linked list, that's okay. But it's again a linear data structure and you'll have two things pointing to certain elements. So that's how you would imagine 2 pointers. So in your head, whenever anybody says 2 pointers, you have to think of a linear data structure and two indexes. So basically you're pointing to here, we are pointing to index 0 and some index k. Okay. That's how you would think about 2 pointers. Now, in this discussion, we'll specifically talk about three kinds of approaches. Now, I've already told you how to imagine these 2 pointers or what are these 2 pointers. next I will talk about how to solve problems using these 2 pointers. So how to solve problems, or how to create algorithms in a general sense. How to solve problems. Okay, and this will be like 3 approaches. So A, B, and C. The first one will be index-based 2 pointers. Second one would be window-based. And third one will be slow-fast. So we'll talk about each of this in detail. I intend to cover first one today and B and C tomorrow. Yeah, so by the way, so do you guys, let me tell you a brief history about 2 pointers, because whenever I study any algorithm or anything, so I try to see how it relates to previous like the history. So you guys already might know like what was the breakthrough in 1930s for computer science. So that was Enigma. So during World War II, there were these machines which were trying to break the secret code. So what I'm telling you right now is the history of computer science, how computers have evolved, and when we started to see these algorithms coming into place. So in 1930s, during World War II, 1940s, there were computers which were mostly mechanical. So those machines were do just one task. So they were very specific. So they could do just one task. Okay, this is one. And they were mostly mechanical. So there would be levers which would move and that would do the task basically. And then this notion, then people started generalizing it, that can we create some machines which can do many tasks, which can solve many problems. So that was like 1950s. And so during 1950s, there were first computers which came out to be like programmable computers. So programmable means you could program it to do many tasks. And when you think about it, algorithms will really come up in this era, because now the computers are programmable, which means like you can code things, right? Here you cannot code things. You have to make mechanical parts for everything. So here I would say this was the outburst for algorithms. And then you see many popular algorithms here. So slow fast pointers, which we'll talk about in 2 pointer discussion, came during 1956, I guess. And then there was, you might have heard about quick sort algorithm. So this was slow fast. And like many algorithms started coming up during this point when computers started becoming programmable. And after this, now you could imagine yourself, like once the computers are programmable, you can ask them to do something. Now you would want them to do something automatically. So then people started talking about machine learning and AI. So that's like the logical, I would say, like how this field has grown up. And it's, as you can see, it's not very old field. It's like early 1900s we started thinking about computers, and 1950s we had a reasonable like programmable, and 1960s or late 1960s we started talking about machine learning and AI. So it's a interesting field, I guess. Yeah, so this is most important for us. During 1950s, we started seeing these algorithms, and this was so. When I talk about slow fast, I'll discuss, like, there's some interesting history behind this. I'll tell that during that session. But right now, I think this is a good picture to keep in mind. Also, like, you can try building connections of this growth to other fields, like how politics was affecting each of these breakthroughs. So there are interesting ways you can look at the history, not just in computer science, but how it is related to other fields. For this discussion, I will not discuss because that might be too much detail. Um, so with that, I'll start with our first approach of two pointers today, which is index-based two pointers. So let's start with that. Okay, what does this mean, index-based two pointers? So as I told you, how would you imagine two pointers? You would think of a linear data structure and you'll put two arrows or two indexes in that. Okay, so let me do that. So I'll create an array and I'll put two pointers, okay? Now, whenever I say index-based two pointers, that means the solution, whatever problem I'm solving will have a solution. So the solution will be function of these two indexes. So I'll call this as index 1 and index 2. Now solution will be a function of index 1 and index 2. So whenever anybody gives me these two elements, I can give one of the solution for the problem. That's how you would think about index-based two pointers. Now, if you can imagine that, I'll give you an approach, or like step by step, how would you actually solve a problem, and then we will see with an illustration how to apply those steps. Okay, so now we will see like steps to solve, and then I will illustrate each of the step. So just uh, just listen carefully what we are trying to do here. So whenever you are having a problem, the problem is related to a linear data structure. That would be an array or linked list. Okay. And okay, so there are three steps basically. And the first step would be you have to position the two pointers. So what does position mean? Can anybody tell me, like, if I just give you this sentence, what would you interpret out of this?
To make these pointers point to specific indexes of the array.
Right. Yeah, that's correct. Who was speaking? Hello?
Yeah,
Can
this
you
is
hear me?
Suraj.
Okay, yeah, great, Suraj. Okay, so that's correct. So you will initialize the position of the pointers to specific locations. Okay, we'll see how to do that. And once you initialize the position of two pointers at certain locations, now what would you do is you will analyze that situation and will make a conclusion. And finally, once you make a conclusion, you will decide which pointer to move, and you will move one of the pointers. Okay, so those are the three steps. And Okay, now you would ask, okay, I understand all these 3 steps, but they don't make sense. Like, how would I use? When would I use? So let's talk about when would you use. Like, how would you see, like, if a problem can be solved using 2 pointers, right? Because there are so many methods. So there are some cues which you can follow to see whether a question can be approached using 2 pointers or not. So the first cue would be, you would have question related to array or linked list. So it will be a linear data structure. That's the first cue. The second cue is you are stuck with time complexity. So if you want to improve time complexity and you're stuck at it, so maybe it's a good way to think about 2 pointers. Other than that, I'll talk like more about when to use slow, fast and other things, but like these are the 2 cues. It should be a linear data structure and you're aiming for improving time complexity. Those are some of the cues. And then obviously, once you find these cues, you'll start from the steps, right? You'll position the 2 pointers, you'll then make a conclusion and you'll move one of the pointers. Okay, so is this clear at this point of time? Should we move to an illustration?
So what do you make a conclusion about?
Yeah, so I'll specifically talk about it when I give you an example. You will see what that means. Okay, so let's move. And if you guys find anything is going very fast, just let me know. We can slow down the pace, or if you think something is going very slow, let me know. We can increase the pace as well. Okay, so let me start with a question, and you have to solve that problem using some approach. You're not supposed, or you're not expected to use 2 pointers, just solve it. Okay, so I'll tell you the problem. I want to know like solutions from you guys first, and then we'll start thinking about it. Okay, so we'll build up from the very basics. So the problem is this: you have a linear data structure which is an array, and as you all know, array has fixed size. So I'll close the other end as well. So this is my array. These are the boxes, are the elements, and this array is sorted. So elements are, this is a good array. So elements are like sorted. Okay. Here, let's say I have something 15. Now, this is my array A. And then I also have a key K. Okay, key is, let's say I give you some number. Let's keep it to be 11. Okay, now the question is, you have to find a pair of elements which add up to K. So you have to find pair of elements in this array A. So in A, which add up to K. Now, this is our question. I want to hear solutions from you guys. Like, give me some algorithms how to do that.
So I guess we can run 2 loops, and we can just basically end up adding up each and every element of the array to see if it gives the key.
Right, right. So yeah, that makes sense to me. Anybody else? And what will be the time complexity of that algorithm?
N square.
Right. So what we are saying is, basically what we'll do is we'll run 2 for loops. So one for loop will be I from 1 to n, So my first element would be a of I, and within this I'll run another from j equals I plus 1 to n. My second element will be aj, and then I'll check if first plus second is k, right? And then I'll return from here. Okay, this is what you were trying to say, right?
Yes, sir.
So let me change the question a bit. Now, if this array was not sorted, so let me write it here. So this was sorted array. And now let's think about when the array is not sorted. Will the same algorithm work?
Yes, sir.
It will work, right? Because we are not using that property here, right? So same algorithm will work for sorted and non-sorted case. So this works. Now you have seen that we are not using the property of like it's already sorted. Keeping that thing in mind, can you think of an algorithm which uses that property and probably reduces the complexity?
Sir, we can use a two-pointer method, a left pointer and right pointer, and we'll sum up the left and right pointer. If that equals to, if that is greater than the key, then we will shift the right pointer to the left side, and if the sum is less than the key, then we will move the left pointer to the right side.
Right. So I understand your solution.
So one
Yeah, so
more way
that's
can be this, that we take an element and then we binary search for 11 minus that element in the rest of array.
right. Yeah, so you have already studied binary search, right?
Yeah,
So
yeah.
that's a very good application, I would say. Okay, so do you guys understand so who just spoke this solution?
So Mantavya.
Okay, yeah. So thank you, Mantavya. Let me share that solution again. So what Mantavya just said is, okay, the array is sorted. We had this 1, 2, 4, 6, 7, and whatever, 15. What Mantavya was suggesting is we'll do from I1 to N. My first element would be A of I, and I need to search is equals to key minus A of I. Now to get that sum, I need to search whatever the difference is between the target, so that is k, and the element which I already have. So I need to search this, and then I'll do binary search for this. So binary search you already know how to do. So you'll do binary search of this search element in A. So this will, and what will be the complexity of this algorithm? Can anybody tell me other than Mantavya?
N log
N
n.
log n.
Yeah. So this will be order n log n.
Hmm.
So did you see, like, we used the property and we came from order n square to order n log n. Now let's think of how big the difference is here. Like, can you guys imagine how big this difference could be? So let's start with some value of n. So let's start with value of n is 10. So n square and n log n. So n square would be 100 and n log n would be 10 log 10. So what is log 10? Can anybody tell me, like a rough estimate? Assuming the base is e. So value of e is around 2.7, I guess. So this will be close to 3, right? I mean log 10 value. So this will be about 30. Let's increase 10 n. So n would be, let's put n as 100. So this will be 100 square. So that would be 10 power 4. And this would be 100 log 100. Okay. And so this would be 200 into 3, which will be around 600. Let's increase the n drastically, 10 to the power 9. So this will be 10 to the power 18. And this will be 10 to the power 9 log this. This will be 9 into 10 to the power 9 into 3. This is 27 into 10 to the power 9. Now, can you see the difference? Like this is 10 to the power 18 and this is like order of 10 to the power 10. It's like, it's more than, yeah, it's like this is square root of the other thing. So it's a huge increase in time complexity. So yeah, I was just trying to make you guys appreciate like how much you have improved the algorithm. Okay, so that's good. Now suppose you are in an interview and somebody asks you, okay, I'm quite happy with n log n, but I want to increase it further. So you guys made it from n squared to n log n, but now you guys know we all are greedy, right? So whatever we get, we are not happy with it. So I'm still not happy. So we want it order n. So that's our goal. So think of the two queues now. We have a linear data structure and we are aiming for improving time complexity. Okay, so this is improving time complexity. So what should click in my mind? 2 pointers. So let's see how we can do this using 2 pointers. Is everybody with me? Did I lose somebody? Oh, where's my chat? I can't see the chat. Anyways. Okay, so now we are aiming from n log n to order n. Okay, so let's start thinking about it. So 2 pointers, we talked about 3 steps. First would be position. Second was make a conclusion. And the third was move the 2 pointers. Okay, now let me do each thing step by step and see. So this was my, yeah, guys, you can tell me whether you're following or not. I'll implicitly assume you're following me, but if you're not, or if you are, please let me know. Okay, cool. Yeah, let's make this session more interactive. I shouldn't be the one who is speaking every time. I want you guys to speak as well. So coming back to our good array. So good array was sorted array. Now I'll position the pointers. Okay, that's the first step. Now, first thing that comes to my mind is let me position the pointers next to each other, side by side. Okay, and let me see if I can make a conclusion using this. So that's my trial one. And I've positioned the 2 pointers next to each other in the beginning, at the start of the array. Now, what this means is, okay, the sum is, by the way, key was 11 or the target was 11. Now, a of p1 plus a of p2 is 1 plus 2 is 3, right? Now I'm less than key here, 3 is less than 11. So that means I should increase the element, right? I should somehow try to bring the sum up. Okay. Now at this point of time, I'm confused whether to increase P1 or increase P2. Okay. I'm in a confused state. So I cannot make a conclusion really, like which pointer to move. So conclusion is basically finding a property and deciding whether, like, which pointer to move. So at this point of time, I'm totally confused. Like, I don't know which pointer to move out of these two to increase the array, the sum. So that was not a good trial. So this was a fail for us. So yeah, we won't, let's give it one more chance. We won't reject it right away. So now what I will do is I'll position the pointers. Let me use a different color to position the pointers. I'll position one of the pointers at the start and the other one at the end. So this is just from my experience what I'm doing. I just experienced that while solving questions, either I have to place next to each other or I have to place at start or beginning. Now let me see if I can make some conclusion. Okay, so a of p1 plus a of p2 is 1 plus 15, which is 16. Now, is this less than k or greater than k?
Greater.
It's greater than k, right?
Greater than k.
Now, what that means is I need to bring the sum down. So this sum, I have to push it down. So can I make a conclusion here whether to move P1 or P2 and in which direction? Can anybody tell me?
P2 to left.
Move P2 to the left.
Right, so here we can make a conclusion. Okay, since I need to bring the sum down, I can move P2 one step back because that would reduce the element. Now think about it, why you can do that, because the array is sorted, right? Now we are tying it back, the whole loop is tied back. You have a sorted array, you're using that property, and now you can imagine this algorithm would be order n, right? So let me write the full condition in the next page. So you would have this array. So you guys placed the pointers at the beginning and at the end. So this you called P1 and this you called P2. And what you said is if A of P1 plus A of P2 is greater than K, then we will do P2 minus minus. So we'll move. So let me color code. So what I will do is P2 minus minus, which means I'll move this P2 to here. Okay. Now, if the condition was opposite, so let's say if A of P1 plus A of P2 was greater than, less than K. So if this was less than K, what will we do? Can
Increase
anybody
P1.
tell? Right. So what I will do is P1 plus plus, and that means I'll move this pointer to right, and this will come here. And what's the third condition? And what will I do there? Can anybody tell me?
When it becomes equal to K.
Right, it becomes equal to K. And what do I do then?
We'll increase P1
Return
and
the two
decrease.
values.
And
Yeah, we found an answer. So we just return the answer. Okay. And like how long will I run this loop? Like what will be the termination condition? When will I end doing this?
When P1 is smaller than P2 or greater than P2.
Right. So this we will keep doing while P2 is greater than P1. Okay. So does that make sense to everybody?
Yes, sir.
Now, okay, this is the pseudocode, or this is the approach and the thought process which we went through. Can you all think what is the time complexity now?
At worst case, it will be around O of n.
Right. So yeah, it's order n time complexity. Just a second, I need to. Yeah, so we found an algorithm with order n time complexity, and if you recall, we started from n square, then using your binary search knowledge, we brought it to order n log n, and now we even further pushed it down to order n, right? Okay, so we satisfied our greed of bringing the time complexity down. Can you guys code it? Can you imagine how code will look? So let me share the link to the lead code and let's start coding. Okay, so I'll give you guys few minutes to start yourself, and then I'll show you how I did this. Oh, where did my Chrome go? Okay guys, I've just shared the link of to some problem. So the title of the problem is to sum. When you'll read the question, when you understand the problem, you'll appreciate the title. Why is it to sum?
Sir,
Yeah.
sir, am I audible?
Yeah, go ahead.
Sir, with the help of unordered map, the complexity can also be brought down to O of n, right?
Yeah, that you will do when you will read hash tables and all. But that's right.
So the complexity that we get there is also almost O of n, because accessing an element in the map is of O of 1. So at max we'll have to traverse the array n times. So that will be O of n only, right?
Right. So that will be, average case would be order n. Worst case could be order n square there. But
Sir,
yeah,
how
practically speaking, it will be order n.
Sir, how worst case can be order of n square, because at max we'll have to traverse the array once only.
No, so to find the element in a hash table, you can take, if the hash function is very bad,
Hmm.
it can take order n.
Means accessing an element in an unordered map can take up to n square also. Means
Up to
up to
n.
order n also.
Yeah, if the, like, think of it this way, if all the elements were same, I gave you all the elements as 0, or
Yeah.
it
Yes.
will try to find that element, or maybe not. So accessing an element in a hash table can be order n. So if you have already studied hashing, you might know what is linear or chaining hashing, right?
Yes, sir.
You
But
put,
as far as I know, that in an unordered map, if we want to access any element, then at max it can go up to O of 1 only.
yeah, that's, so if you access n elements, the average case is order 1. That's what I'm saying. So worst
Okay.
case would be order n, but like hash functions are good enough to give you order 1
Okay.
complexity. Yeah.
Okay. Okay, sir.
So when you study hashing, like, we'll mostly talk about order 1. We won't say it's order n.
Oh,
But yeah, you're right.
okay, sir.
So I've just shared the link to the question, guys. I want you to code, and then I'll start coding in front of you and see where we reach. Okay. Okay, guys, you have 1 more minute, and then I'll start coding with you guys. Did anybody get accepted?
Yes, sir.
Okay, good. Okay, so whoever got accepted will help me write the code, and I'll make some mistakes. I'll see whether you guys can find it or not. Okay. So, okay, let's start coding. So let me share my Chrome. Can you guys see the Chrome browser?
So
Let me zoom in a bit. Okay. So I'll start with putting size of our array in a variable, and so I need to code up 3 steps, right? I'll first position the pointers, and then I need to do what? Make a conclusion, and then I need to move the pointer. And what do I need to return? I need to return a vector of int which contains the 2 elements which sum up to target. So I'll create a vector of int, vector of integers, and let me call it result. Okay. Now I will at the end return the result. That's what I'm supposed to do. Now help me out
So we
how
have
to.
just return the indexes, not the vector.
Okay, I'll put the indexes in the vector. Is that okay?
Yeah, that's one.
Yeah. So how should I position the pointers? Help me out here. So I have 2 pointers, P1 and P2. What should I do with P1 and P2?
P1 is equal to 0 and P2 n minus 1.
Okay, so we position the pointers. Now I will do a while loop, right? I just discussed why, like, you have to do the same thing till P2 is greater than P1. Is that okay? So we made some conclusions. Somebody help me with that. So what should I write first?
If numbers P1 plus numbers P2 is equal to target, we break out of the loop.
Okay, so I break out. So that means I found a solution, right?
Yes, sir.
And okay, let me do this. Since I'll keep doing numbers P1 plus P2, I'll put it in sum here, right? So I'll call it current sum, which I will just say as numbers P1 plus P2. So if current sum is target, I'll break. What else? What else should I do?
If current sum is greater than target, then we'll decrease P2 by 1.
So if we are overshooting the target, we need to reduce the P2, right?
Yes, sir.
And what's the, and if I'm under, like I'm
Then
not
we'll
at target, we just,
then we'll increase P1 by 1.
yeah. So we have done the moving of the pointers as well. Okay. So this is moving the pointers. And how do I return the result now? Is our indexes already in my result, or I need to do something?
We need to push the results into a vector, the P1 and P2 pointers.
Okay, so I'll push back the indices P1 and I need to push back P2. Is this correct, or do I need to do anything else?
So push
The
back
array,
P1 plus 1 and P2 plus 1.
Okay, so these are not zero based. Anything else? Does this look good? Is there anything? So are we guaranteed that P1 and P2 will sum up to target? Like what if we don't get a pair which sums to a target? What will happen then?
it is given that we will always have an answer.
Okay, so we'll always have P1 and P2, right? Does everybody understand that?
Yes, sir.
If that was not the case, what I would do here, I would put a if condition to check whether P1 and P2 add to if current sum is target. Okay, and then inside the if condition, I would put these two statements, pushback statements. But since I'm guaranteed that I'll have a solution, I don't need to do this. Okay, so is the syntax correct? Let us run and see. Okay, looks like, and let's submit. Okay, we are good. So that is 2 pointers for you guys. And do you guys have any questions on this problem specifically? If not, we can move to the other problem. Is everybody with me?
Yes, sir. Clear.
Yes, yes, sir, clear.
Okay, good. Okay, so now I will give you one question. You have to do yourself, and you have to help me solve that question. Okay, so let me share the link. We can move a bit faster if you guys want, but is my pace okay? Should we increase? Should we go faster? You guys can speak up.
No, sir, we're good.
Okay. Okay, let's try this question now. By the way, Mukhar, did you understand the question? You just joined a few minutes back. Did you
Yes, sir, I got it.
Okay, good, good. Okay, so this is the question for you guys, and read the question. If you already know the question, just start coding. Think about the 3 steps which we talked about. Okay, let's understand the question now. So you are given an array, and each array has an element. Let's take one example from lead code. So 186.254.837. 186.254.837. Okay, so you are given this array, and what the elements of this array mean the height or the elevation at that point. Okay, so 1 would mean that there is one height of one pole there, and 8 means this height 8 pole, 6 would mean there is height 6, and so on. Okay, and then there is height 7. This is 7, this is 8, this is 6, this is 1. Now what we need is we want to find the two indexes which will hold the water most. So what that means is the 2 poles will be the end of a container or a jar, and you have to imagine that holds the water. So you have to find the container which holds the most water. So let's say I was taking index 0, so that is size 1, and index 2, which is size 6. So how much water will it hold? Can anybody tell me? So this is height 1. Can anybody tell me how much water will it hold?
One unit, like whatever.
It will hold 2 units, right? I mean, 1 will be the height and the width is 2, right? So water will be 2. Is that okay? Or did I do anything wrong?
Okay, sir.
Yeah, everybody with me? Okay, now quickly answer me, what if I take these two? Let's pick 3, the last 2. If I take last 2, what will be the amount of water which I can hold?
6 units.
How 6?
So difference is
3,
2,
right?
right?
Difference is
3.
So 3
3
into
units.
1, right? So it will be 3 units. Okay, one more try. Let's do one more. let's pick 5 and 8. How much water can I hold?
15.
15.
15.
So how 15? So 5 will be the height and 3 width. Okay, yeah, 15. So you guys get like what this means, right? How different containers will hold the water. So what we need to find is we want to find the indexes which form the container and which holds the maximum water. So is the question clear? And can you guys tell me what will be the solution for this particular array for our question? What are those two indexes and what is the amount of water? So I need these two things from you guys. So what are these two things for this particular array?
The last index and the second index.
Okay, so I will just write the elements. So elements would be 8 and 7, right?
Should be 49.
Yeah,
And
and
amount
49
of,
should be.
so the width would be 7 and the height will be minimum of these two, right? 8 and 7. 8 and 7. So which will be 49. Everybody with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So we understood the problem, and now what should be the approach? Let's think of very naive approach first. Let's not go into 2 pointers. Let's think of how would you do it if you just had the knowledge of loops?
So find the volume for take 2 for loops. Find every possible volume.
Right. And
then
take
find the
max of,
maximum.
right? Okay. So does everybody follow that? So what we'll do is we'll keep a max water kind of variable, which will be 0 initially. And then what we'll do is we'll run a for loop for I from 1 to n. And then we'll get our first, or let me say, it will be easier to understand if I say it, left. So I'll get my left wall. So left wall would be a of I. And then for this left wall, I will find the right wall. So I'll start from I plus 1 to n. And my right wall will be a of j. Okay, and the amount of water, current water would be what? So it will be minimum of ai in comma aj into j minus I plus 1, and maximum water will be max of current water and max water. Is that clear? The naive way of solving. So we have these two loops basically. And for every combination of walls, left and right, we are finding the amount of water and we are taking maximum of it. It won't be j minus I. Can you, okay, yeah, it will be j minus I. My mistake here. So that means you guys are paying attention. That's a good thing. Okay, so what's the time complexity? So whenever we write an algorithm, we We just care about one or two things basically, time complexity and space complexity. So what is the time complexity here?
N square.
X square. It should be absolute difference of j minus I. So do you guys think this should be absolute difference of j minus I? Yeah, so j is always greater than I, the way I've written the loops, right? If I would have written from 1 to n, then probably I need to take absolute value. Okay, so yeah, what I was speaking about was about time complexity. So time complexity is order n square, but we are greedy people. We need better time complexity. So it's a linear data structure and we are greedy. We should do 2 pointers. Now you have to think of an approach where you use 2 pointers. So let me clear this. Now somebody has to start the discussion of 2 pointers from you guys. Somebody has to help me do that.
Sir, we'll be looking for two indices where the value is where like the smaller value and multiplied by the difference of the two indices is maximum.
Right. So I told you 3 steps. So I am very, I don't understand things very quickly. So I told you 3 steps and I want those 3 steps from you guys. Somebody help me with those 3 steps. So my first step was positioning the pointers. Okay. How would I position the pointers?
We initialize pointers like we did in the last
Okay,
question.
That's
Pointer
what.
1 at 0 and pointer 1 at the last index.
But I'll always start with doing like this because I don't know what will work. Okay, so let me start
Yes.
with this and
Yes.
let's see if it works. So, okay, somebody now just help me out with this. So this is P1 and this is P2. And what was the elements in the array? So this was 1 and 8, I guess, right?
Excuse me, sir. Sir, can't we first sort the vector?
Okay, so we'll come to that approach, but
That wouldn't work, I think, sir.
if you sort the vector, you're changing the positions of the walls, right? Like you will lose track of, you also need width.
Okay, sir.
So let's say I have 1 and 8 here from the example. So my A of P1 is 1 and A of P2 is 8. So I take minimum of these two. So that becomes the height, and width is P2 minus P1, which is 1, and height is also 1. So amount of water becomes 1 into 1, which is 1. Now what? Now what should I do? Can I make a conclusion? Yes, no. If yes, then how? If no, then why not?
No, sir, we can't.
Why can't we make a conclusion? Or if somebody said yes, how can we make a conclusion?
Sir, firstly, if we will try to move the smallest value pointer, like we will try to move the P1. And if we interchange these, like we would move P1 forward of P2, then we will lose track.
Right. So you were saying no, right? We cannot move the pointer.
Yes, sir.
Okay. And somebody was also saying, okay, we can also move the pointers. Can you speak? Whoever was saying that.
And sir, this will also contradict our calculating W property. This will give us negative value.
Okay, so what I see is I have these two pointers. Now I found the amount of water, but now my question is whether should I move P1 or P2? I don't know, right? I can move anything, so I'm in a confused state. Like I cannot make a conclusion. I cannot say anything about P1 or P2.
So if we increment P1, won't the volume of water become 0?
Yeah, if we increment P1, the volume of water will be 0, but then I mean, that will reduce the amount of water, but can you increment P1? That's the question. So you will only, okay, let me go through try to and you will see what I mean by making a conclusion.
So in this case, the maximum complexity can also be O of n square, right?
So this case, the fail was try. I mean, the try was fail. Yeah, the try was fail because I cannot make a conclusion. Here I was confused. Let me do try to and then you guys will understand how complexity will be order n and how it solves the question. Okay, so the last element was what? Last element
7.
was 7. Okay. Now I position pointers first and last. Okay, so let me think of conclusion. So my height is minimum of again a of p1 and a of p2. Okay, these two elements, and that is 1. And width is what? How many elements are there? Width is 8, right? So amount of water becomes 8. Now can I make a conclusion here? Can anybody see if I can make a conclusion? So this is my height 1. This is my height 7. Okay, let me put it this way. So these are the two towers, right? And this is the amount of water we found out. Okay. And what I'm saying now is for P1, so for this guy, you cannot have anything better than this. Can anybody understand that? Why you can't have anything better for P1?
Because the width is maximum.
Right?
Because
The width is maximum and also the height. So anything longer than P1, water will overflow. Does that make sense? So for a point, what will be the best thing? That it is filled up to its full height and it gets the maximum width. Is that clear? Okay, let me redraw it. So this was 1 and this was 7. So what we are saying is this is the, so my claim 1 is this is best for best case for 1. And now you guys have to explain why this is the best case. So there are two things to it. First thing is, this is the best case because you're filling full height 1. So you're filling full height for 1. So this is the full height for 1. You're filling full height. Anything more than 1 you cannot fill for a container which has the wall as 1, right? And second thing is you are getting the maximum width. So you are getting like the last element, the maximum width. So is this claim clear?
Yes, sir.
Yes, sir.
So can I make a claim to, okay, I have found solution. I have found best solution for 1, and now I can increase P1. Can I make this conclusion too based on C1?
Yes, sir.
Yes, sir.
Okay, so is anybody still struggling with this? I can repeat the point.
So, shouldn't we be increasing the minimum one? Like, not just P1, but then, like, aage, if we get another,
Right.
like, we should move the minimum one, right?
Yeah, so we always achieve best case for minimum. Now let's generalize it. You're right. Let's generalize it. So can we say whenever we compare two elements, we find the best case for minimum? And then we are filling for full height for minimum, and then we have found best solution for minimum, and then we can increase minimum. Can you guys see this?
Yes, sir.
Okay. Now, okay, we found that now positioning the pointers at start and end, we can make a conclusion. Can we write the approach? Can you help me write that approach now?
Yes, sir.
Okay, let me bring the array back. So this is my array. So this is P1 and this is P2. Now I give you A of P1 and A of P2. Okay, now help me write the three or whatever conditions are there. What should I do right first?
We will compare the values of A of P1 and A of P2.
Okay, let me do it for you. So if A of P1 is greater than A of P2,
then we will decrease the value of P2.
Okay, so here P2 was minimum, so I found the best solution for P2. So I can now move the P2 left, right?
Yes, sir.
Okay, else if?
We will increment P1.
I can directly write else, right? Because if they are equal, it doesn't matter whichever one you increase or decrease.
P1,
so I
sir.
can just ignore all of this stuff and I'll say just increase P1. So do you guys see how I merged the two conditions, like the equality and the other comparison?
Yes, sir.
Oops. And what is the amount of water we can compute at this point of time, right?
Yes,
so amount
sir.
of water will be minimum of A of P1 comma A of P2. So this will be height. And what will be the width? Width will
P2
be
minus
P2.
P1.
And what is the termination condition? How long will I keep doing this?
P2 greater than P1.
So while P2 greater than P1. And now since I have the whole approach, can you guys think what the time complexity is?
It will be ON.
Yeah. Does everybody understand why this is ON?
No, sir.
So basically, why this is ON? Because you're just making one pass. So this P1 and P2 are just iterating through the array, right? And you stop when P1 and P2 are like, when they just cross each other. So P2 comes this side and P1 comes this side. So you just stop there. So do you get it?
Yes, sir.
Okay, so does this satisfy our greed that we need order n? So we started from order n square, we came down to order n. Yeah, so equality condition won't matter. Can you think why it won't matter?
Sir, we will considering equality in the else part.
Yeah, but I can increase any pointer, right?
Yes, sir.
For that case. And
yes, sir.
why is this correct to increase P1? Like, why is it not wrong? Can anybody tell me? Pratik, can you speak what you're trying to ask? I don't get from your message.
Right. So if I increment P plus plus P1 to get the value of 2, and I'll get like a maximum height of 2, and 2 and 9 ka difference. Oh, sorry, my bad. I kind of
Yeah.
messed up on this one. Sorry.
Yeah.
Right.
Okay. So if the heights are equal, it won't matter because you have found the best solution for both. So you can increase or decrease any of those. That's the idea. So with this approach, can we code quickly?
So
done,
Yeah.
sir.
Oh,
Can you
done.
please go to the
Wow.
previous page?
Sorry.
The previous sheet of the whiteboard.
Oh, I've already cleared that. Just a minute. I have it saved. I'll pull it out. Documents. Okay, guys, start coding if you have not already. Try submitting the solution.
Yes, sir.
Wanted
Already
to
done.
ask, like, if we are optimizing the height, shouldn't we optimize height and width both? Like in the minimum case also, there might be a situation where width can be optimized.
Can you say that again? I don't quite
So
get
like
it.
we have two factors here, right? Height and the width. The height we have optimized with minimum of A of P1 and A of P2, but for the width part, that should be maximum. So shouldn't we
And
start by seeing the maximum width on both sides and then seeing if the height is
so we are already maximizing the width. Can you see why we are maximizing the width? Because we are keeping pointers at maximum distance.
okay? Okay, got it.
So this is the previous slide. Can you guys see the previous slide?
Yes, sir.
Okay, so let's start coding then. Any other doubts?
So when we are maximizing height, our width can be minimized in the meanwhile. Like in an example, when we'll iterate, our P1 is pointing to 6 and
Right.
4.
Right.
So when for 4, the maximum capacity will come as 12.
Right.
But if we go left of P1, then it can come as like 4 into 4, that can be 16.
That's a good catch. So is there anything wrong in which what we are doing? So let me explain you. So let me explain your doubt to other guys. I think that's a very good question. So what the doubt is this. So I said that there are these two pillars, 1 and 7. So this was index 0 and this was index 8 or whatever. This was height 1, this was height 7. So I found the maximum for leftmost and I moved the pointer. Okay. But while I'm moving the pointers, P1 and P2, okay, this was P1 and this was P2. Am I still ensuring the maximum for them? So
Yes, sir. Because we are moving the minimum height pointer.
right. So if let's say I moved P2 here and I found a, so let's say I moved P1 here in the first step and my height here was whatever the height was, I think it was 8, right? So this was 8. And then I moved, so when I found 8, then I moved P2 to the next point. So my step 1 was moving P1. So this is my step 1. And then my step 2 was moving P2 because 8 was greater than 7. So this was my step 2. Okay. Now let's say at P2, I find a height of 1. Now again, I'll find this much water, right? But if you see closely, I could have taken this one as well with this one, right? And that would have increased the amount of water. So am I doing anything wrong here?
No,
Do you
sir.
guys understand the question?
Yes.
Sir, can you repeat this once again?
Okay, so do you understand the two steps? So first step was I moved P1.
Yes.
And step 2 was I moved P2 because of these heights. So this was minimum, and then for step 2, 7 was minimum. And
Yes.
now my new P1 and P2 are this. So P1 is here. Okay, no, not this. So P1 is here. Let me rub this. Yeah. So P1 is here and P2 is here. Now, what will be the amount of water I'll compute at this point of time when P1 and P2 are at these positions? So that will be this green portion.
Yes.
Okay. But if I would have taken for this P2, for this wall, if I would have taken this wall, then amount of water would have been this. Like there will be extra green portion.
Yes.
So am I doing anything wrong?
No.
So who was asking the question? I forgot. I didn't see her name.
So Rashmi.
Yeah, so this is your question, right? Like, can we not move back
Yes.
and find, yeah. Okay, so let's see why this is not wrong, or whatever we are doing is not wrong. So I'll make, let me undo it. Okay, so I'll make 2 claims and then you will see why this holds. So first is, when I was having this 1 and 7 thing, I found best solution for 1. Is everybody agreeing on C1? That I found the best solution for 1, which lies at the leftmost end.
Yes, sir.
Yes.
Okay. Now what I'm saying is, since I found best solution for 1, now I can ignore it. So what that means is, anything which involves 1 will be worse. So from C1, can you see why C2 holds? Because I found the best solution. Now you bring anything to me which includes this 1, that will be worse. So now I can treat it as, okay, this is not part of array anymore, and I can just ignore it. Like, that's the thought process. Can you see why C2 holds?
Yes, sir.
And
Yes, sir.
now with that, what will be my new array? So I'm back to this problem, right? Now I'll have 8 on left side and 7 on left other side. Height 7 and height 8. And then again I can say that, okay, I have found, okay, I have found best solution for 7. So this best solution is best solution in the current array. So here, let's say I'm just ignoring this previous one. So this is being ignored because I've already found the best solution for this. So now on, I'll ignore this. Now I found the best solution for 7 in the current array. And then I can again say C1 and C2, the 2 claims for 7. And that goes on. So now can you see why the same thing will hold when P1 and P2 are still somewhere in the middle?
Yes, sir.
Does that clear your doubt, Rashmi?
But what happens when P1 comes to 6 and P2 comes to 4?
P1
In that
to
case,
6.
we can get more better solution for 4.
Yeah, you can get more better solution if you consider the whole array. But what I'm saying is, whatever elements you have ignored, you found their best solution. You can't have better solution for them.
For ignored elements, it's fine. But what about the elements which are present in our current array?
So for the current array, you will find the best solution for that in the current array. But if you're getting a better solution for the ignored elements, that you're ignoring because the ignored element already have their best solutions. Even if you have this 4 with them or 6 or 4 with them, that won't be best for the other ones. I mean, they have found their own best. Do you get the point, what I'm trying to say?
But 4 can have best with 6 that has
Yeah. 4 can have best with 6, but 6 has already got a better solution. So you cannot pair 6 with 4. Do you get that? I mean, since you've already found best solution for 6, anything with 6 now will be bad. So if you're including 6 with 4, that's not as good because you have found a better solution for 6.
Okay, got it.
Because the width of between two values it decreased.
Right, width also decreased, and since we have found best solutions for the elements which you have already done, so whenever we are moving the pointer, we have found the best solution. I mean, the current best solution for them. Do you guys get this? And can you relate it to these two claims?
Yes.
Yes, sir.
So since I found the best solution, now think of it like I'm starting again. Now I can ignore the element for which I found the best solution. I can say, okay, ignore that element. I found the best solution for it. Now I'll just concentrate on the new array.
So then how are we exactly comparing all the best solution and getting the maximum out of, like, we are getting the maximum out of all the best ones, right?
It's like, yeah, it's some optimization which is not comparing the absolute bests, but it is like the current best it is computing.
We got like around 5 best among the whole array when we are traversing. Then apart, like, in among all of them, we have to find the final answer, right? Which two poles we should select.
Right. So we'll have also a maximum water outside, right? A variable max water, which we'll keep track of.
Okay, got it.
Yeah. So can you guys code now? So this you don't have to really write and do this. You have to think in your head. So this is part of your brain. So this is your brain. Maybe you have bigger brain. So you don't have to write it formally. You have to think of this and you have to start coding. So does that make sense?
Yes, sir.
Everybody with me? Did I leave anybody behind? Okay, if that is clear, let's code it. It's a lot of discussions, lot of theories. Done with code? Okay, so whoever is done with code, just help me so that we can finish it quickly, okay?
Yes, sir.
Okay, let me share my Chrome. By the way, do you guys have access to the lead code, the DSP batches lead code?
Yes, sir.
Okay, so I'm just coding there, so you guys can go back and look at the solutions, whatever we did in the class. Okay, and can everybody see my screen?
Yes, sir.
Okay, good. Let's start coding then. So I always start with n. So I will have the size of height array. Now I need to do 3 things: position, conclude, and move. And I'll store a variable max water and I'll initialize it to 0. And I'll return max water. Okay, now I need your help. So how do I position? So I have P1 and P2. What do I do?
Initialize with 0.
Okay.
And n minus 1.
Okay.
Define a loop while p2 greater than p1.
Okay. So I can move this to inside. Okay. Now let me define two variables, left wall. So that will be a of p1, and I'll have right wall, that will be a of p2. Now what do I do?
Find the minimum of them.
Okay. Let's say if left wall, if right wall is larger. Okay. What do I do now?
Current water is equals to left wall star p2 minus p1.
Okay, so the height is the left wall and the width is p2 minus p1. And I increase p1.
Not right now,
Else?
sir.
Not right now?
Yes. We will increment later while comparing.
Okay. Else current water will be what? Right wall into
p2 minus p1.
Okay. Now
Move pointers.
okay.
We can do that, sir, with this.
The same I can put it here.
P1 in the if part.
Yeah. And is that all? Am I missing anything?
Comparing the current water with maximum water.
Okay, so I did conclude and move together actually. And now I need to do what? I need to compare max water with current water. So I'll just do max water is max of max water and current water. Is it good?
Yes, sir.
Everybody following this?
Yes, sir.
Let's check.
Sir, you need to change the vector name, sir. It's A. It should be height.
Oh, okay. Is there anything else I'm missing? Height, max water. So here I put height. Looks good now, okay? Okay, so let's submit. Okay, so this is done and you guys can access the submission. By the way, time check. Okay, so we have 5 to 10 minutes for the session, and I don't want to start new topic now, and I'll post more questions on this so you can try using this index-based two-pointer approach. So you understand the index-based approach, like whenever we have these two indexes, we can find a solution. So that was the index-based two-pointer. And if you recall the two problems which we did, so one was this water problem and the other was the two-sum problem. And whenever we had a pair of indexes, we had a solution. And we were keeping track of that solution. So that's the index-based two pointers. Now, I think you can do some questions. I'll post that as part of your homework. Okay, with that, I can take any questions if you have, guys, for today, and we can wrap up the session.
So
Yeah.
in this kind of question, so if they ask us also the index of what indexes are providing this maximum volume, how do we do that?
So you can store the two indexes here, right? You can store first and second. Okay, and
so you don't need
then
to write it. Anyway, when you come out, P1 and P2 will already be there, like when you come out of the while loop.
no, when you come out of while loop, you won't be at the maximum position. So you have to do something like this. So if current water is greater than max water, so you will do three things. So you will do max water is current water, and you will also say first is P1 and second is P2.
Okay.
Okay.
So that you already changed the pointers before, right?
Sorry, your voice was a bit.
You changed the pointers before, so you should change the pointers after, if that's the case.
Oh yeah, so you have to do P1 minus 1 or whatever. Yeah, you're right. So you have to do something else. So you have to maybe move these out of the if part and
Yes, sir. We have to move them outside this.
outside. Yeah. Yeah, so you guys understand how you can do that, right?
Yes, sir.
So max water, let me put the code back so that it's not wrong. Any other question? First and second, I can just remove.
So max water equal to max of max water and current water. It is running every time in the loop, sir. So why don't we use a if loop? And if max water is less than current water, then only we update.
Yeah, so this is one line for that. I mean, you can do either of those, essentially.
Okay, sir.
Yeah, because if condition will always be executed, right? Like the condition of if will always be executed.
Yes, sir.
And if that is true, then you will go inside the loop. So it's same. I mean, this will also be one execution and that is also one execution. Okay. Okay, guys, if you have any other questions, I'm here for 5 more minutes. And that's all for today. Thank you for joining. We will do the other two approaches tomorrow. And yeah, we'll learn a lot.
Yeah, guys, if you have any questions, you can ask Sunny. Any general questions also. Like other than he's the most good looking person in our team right now. So no
That's
questions.
not
No questions around that. But yeah, you can ask anything you want. He'll continue tomorrow.
Yeah, continue tomorrow. And I'll be here for 5 more minutes and then I need to do some work.
So can you briefly tell us about the research you are going on? Like you are working on topic that sir mentioned in the introduction. If you
Right.
can.
So I'm broadly working in machine learning, and within machine learning, I'm working on like 3 major areas. One is causal inference. The second one is interpretable machine learning, and the third one is user modeling. So causal inference, I'll describe briefly. You might guys not know about it. So it's more like, it's quite interesting. So let's say there are some patients, right? These days we have a lot of patients because of virus. So you want to find the effect of a medicine, whether it's effective or not. So how do you do it is you divide the patients into two groups, and you give medicine to one of the groups and you don't give medicine to the other group. And then you compare the two groups, like which group is doing better. So if the group which has got medicine does better, then you say the medicine is effective. So there's only one thing you're changing in the two groups, is just that you're giving medicine to one group and you're not giving to the other group. So that's the idea of causal analysis. So you're seeing whether medicine causes improvement, or does medicine leads to better health. Or so this concept can be extended to many fields. Like I'm working on like mostly like when you see an ad on Facebook or Google or anywhere on the web, does that affect purchase? So when you see an ad, do you also make a purchase? Does it have an effect on purchase? So yeah, that's the kind of idea of causal analysis where we are trying to see. And the good part about this is then you can make decisions based on it. So it's quite important for executives in these companies. So if you can say something is effective, that means you can spend money on it, and then that will work out. So it's a high cost, or yeah, if you do wrong, then it's a major loss. But if you do it like good causal analysis, it helps the industry or whatever organization. The other part I'm working on, by the way, if you have any doubts in between, just let me know. The other part of machine learning I'm working on is interpretable machine learning. So that's more of like these machines can predict something. So let's say you guys might know about digit recognitions and CNNs and RNNs, whatever, convolutional neural networks, all different kinds of neural networks. So they work in a fashion, but we don't really understand what those models are doing within themselves. Like what features are they extracting, or how models are looking at the data. So trying to reason like how model is making a decision. So if model says that this image is of a dog, like is it seeing the nose of the dog, is it seeing the eyes, like what part is it focusing, and how the model is making the decision. That's about the other. And the third part is user modeling. So when you're using the web, how can we have a representation for a user? Like so you're visiting different websites, can I encode it in a vector, or can I have a representation for you? So if there's a guy similar to you who is also visiting similar pages, will I have similar vectors for the two guys? So how can I embed users in like Euclidean space or a real space where I can compute different things? And so that's also for marketing purposes. Yeah, so those are the kinds of directions I'm working on currently.
Thank you, sir. Thanks a lot for
Just one question, sir. Hello. Yeah, sir. So we discussed about positioning of the pointers that we do in the first step. So, sir, we discussed two approaches. The first is like two consecutive pointers, and one from the starting and one from the end. So, sir, are there two standards approaches that we follow, or like we can have different approaches as well? We can start from middle also, and then move forward or backward, or sir, like what are the approaches? Sir.
So most of the questions, I mean, I would say 99% of the questions you will start from one of these two configurations. And that is why I was doing these two trials, try one and try two. And in the next lecture, you will see like we will mostly succeed in trial 1 where we do window based 2 pointers. So yeah, I mean, those are the 2 standard ways of positioning.